Alright guys, so we have a look at the next question, which says, okay, so first of all, and this is a common question, it says, so you've got the graph shows a function below, which is f of x is 1 minus x squared plus cos squared x, which is that function, okay, right, and it's drawn between 0 and 4, okay, and it says, show algebraically that f has an x-intercept between x is equal to 1 and x is equal to 2. So they could do this without a graph. Okay. So the principle behind does it have an x-intercept, okay, or does it have a root? Any question which says does it have a root in the interval, what you're going to do is you're going to take the lower boundary and you're going to take the upper boundary. And so either, so if you wanted to say you had a root between x1 and x2, let's just do that again. So if you wanted to say you had there are two scenarios to prove it's a root between x1, come on pen, and one sec, between x1 and x2, you want to show that there's a root between those two things, between x1 and x2. Well, if this was graph G, you'd show that g of x1 is less than 0, you'd show that g of x2 is bigger than 0, and then you'd mention and g is continuous, okay, and therefore there's a root for between x is equal to x1 and x is equal to x2. So basically one has to be negative and one has to be positive. Could obviously be the other way around. You could have x1, x2 in that case. Okay, that was graph f. F of x1 would be bigger than 0. You'd have to show f of x2 is less than 0, and you'd have to say that the function is continuous on those intervals, which means that there must be an x-intercept, okay, between those two values. So if you ever ask, does a root exist between the values, take the n boundaries, sub them in, okay, the one should be positive, one should be negative, and mention that the function is continuous in the interval, okay, and then you've answered the question. So, in this question they say, show that there's a root between 1 and 2. So you're going to work out f of 1, and you'll say f of 1 is equal to 1 minus 1 plus cos of 1 all squared, which is cos of 1 squared. And if you work that out, you get f of 1 is equal to, give me one sec, cos of 1 all squared, and cos of 1 squared is equal to 0,2. So even if you didn't have a picture, okay, we've worked out that when x is 1, y is 0,2, but without a picture you could do the same thing, right? Okay, then you're going to work out f of 2, okay, which would be this point over here, okay, and so f of 2 is going to be 1 minus 2 plus cos of 2, remember it should be in radians, all squared, which is equal to negative 1 plus cos 2 squared. Stick that into your calculator, okay, and you should get negative 0,83, okay, which is less than 0, okay. So your conclusion is, okay, f of 1 is bigger than 0, okay, and f of 2, which is negative 0,8 over there, is less than 0, and then you have to mention an f is continuous, and what that means is that the function has to go through the x-axis, there's no gaps, okay, so the 1 is positive, the 1 is negative, okay, there's no gaps, so it must have a root, okay, in that interval, okay, so an f is continuous, and so you're going to say therefore, okay, what does the question say, there's an x-intercept in the interval, okay. so that answers that question. One is positive, one boundary is positive, y value, one boundary is a negative. Mention that it's continuous, and you're done. Quite a common question. Okay? Right, so even if you didn't have a graph, you'd know that there must be an x-intercept in that interval. Okay. And remember, to show it's continuous, you basically just have to have no denominator. Okay, that's a variable. Right, between 1 and 2, that will make that bottom equal to 0. Now it says use Newton's method to determine the x value of a correct to 1 decimal digit. Well, we can pick some interval, a random thing. We can have a look at the graph and say, well, what does that a look pretty close to? Okay, obviously you're not going to see it correct to 4 decimal digits. So I'm going to say you could pick a as 1, 1, 1,2, 1,3, 1,4, 1,5, anything up to there. Okay, so I'm going to randomly pick x is equal to 1, 2. Okay, if you pick a different x value, 1, 1 or 1, 3, okay, it wouldn't make any difference, right? It's going to head off, be close to that value. So I'm going to use, so for question B, first of all I'm going to say my first guess, educated guess, is 1, 2. Okay? Then I'm going to go to your formula sheet and say, I know from Newton's method, xr plus 1 is equal to xr, what's the name of this function? It's f minus f of xr with f dash of xr. I'm going to be using that method. Okay? Right, there's a bit of a problem in that, well, not a problem, but we've got to work out that derivative, so I'm just going to do it before I get back to that formula. Okay, and I'm going to say, well, f of x is equal to 1 minus x plus cos squared x. So therefore, f dash of x, the derivative, you're not integrating, is going to be, well, the derivative of 1 is 0. Okay, the derivative of negative x is negative 1. So you're going to have negative 1. Here you've got cos of x all squared. So you're going to have to use the chain rule. So it's going to be plus 2. The derivative of the outside function is cos x, times by the derivative of the inside function. Derivative of cos is negative sine x. Okay? And so we're going to end up with f dash of x is equal to negative 1 minus 2 cos x sine x. Right, so now I have f dash of x. Okay, so when you set it up, okay, we're going to go back to this formula over here. You need to write down your formula for this particular function. And you're going to say, right, I'm using x naught is equal to negative 1, 2. And I know that my next guess is equal to my previous x-intercept minus, well, f of xr is going to be 1, minus 1 minus x plus cos squared x. Okay, so 1 minus x plus cos squared x over f dash of x is over here. Okay, so that's going to be over minus 1 minus 2 cos x sine x. So that's my iteration formula for this particular function. Okay, so what are you going to do in your calculator? Remember, you're going to say, right, I've got x naught is 1, 2. So in your calculator, you're going to put that into your memory by going 1, 2 equals all clear. So now 1, 2 is in your memory. Okay. And what you're going to do is wherever you see XR, you're going to press your answer button, remember? So you're going to have, this is what it should look like on your screen. XR plus 1, the next answer is equal to answer minus 1 minus answer. Now when your calculator, you go to squared, go cos answer squared, okay, minus cos answer squared over minus 1 minus 2 cos answer sine answer. So you're going to have all of these answers, answer button, that's what it should look like on your screen. Okay, remember if it doesn't converge, okay, obviously you've made some kind of calculator error. Okay, don't get bogged down by too long though, because you've got most of the marks already up to this point. Okay, but the question said, okay, we want the answer to 4 decimal digits. So you're going to do that on your calculator. You should have got x naught, well we had x naught is 1, 2. You're then going to get x1 is equal to, okay, you should get 1,1589. 1,1589 dot x2, and you get 1,159695. Okay, so up to here, how many decimal digits have we got correct to? Well, we've just got 1,15. So far we've got, if they had set to 2 decimal digits would be done. Okay, but we need, okay, 4 decimal digits. Press equals again to get x3 is equal to 1,159695. So now we have more than enough decimal places because those are all exactly the same. So once it's repeated, it's correct. Okay, so we need the answer correct to 4 decimal digits. So I count 5, 1, 2, 3, 4, 5. Okay, then I round back. So that 9 is going to push that 6 up to a 7. Right, I always do one more than I have to. So your solution is the x coordinate of A is equal to 1,159. And then remember that 6 has been pushed up to a 7 because of rounding back. And there is your solution over there. Okay, diddles. Quite a nice question. Pretty sure I made it enough. Right. Okay.